Today, I'm going to try to help take away some of the confusion on what numbers to use when you're doing mole conversions. You'll definitely want to either print off or copy this version of what I call the mole flow chart. This is definitely something you'll want to put on your study sheet for the test. It comes in really handy and kind of helps organize your thoughts. Another thing that you're going to need for this is your periodic table. So you may as well go on and get that out. A calculator also required if you want to keep any sort of sanity whatsoever. Okay, so I want to show you when you start getting problems that are asking for lots of different things, how this flow chart can kind of help organize your thoughts and keep things in a better perspective so that you're using the right numbers. It's really confusing when you first get started with mole problems on trying to make sure you're not plugging in Avogadro's number when you need a molar mass and vice versa. So this flow chart can kind of help you if you treat it like a map on how to go from where you are to what you want. Let's take a look at the first problem that I've got posted here. We've got 3.2 times 10 to the 24th atoms of sodium. And we want to know how many moles of sodium that is. Okay, well, we know about molar mass. We know about Avogadro's number. We know moles have both of those, but which one do we need? Which one do we want? And this is where this flow chart really comes in handy. You'll notice that I'm starting with atoms of an element. So I'm starting at this part of the flow chart, and I want to end up at moles. So to go from atoms to moles, the tool that I'm going to use is 6.02 times 10 to the 23rd, or Avogadro's number. Notice I do not need the periodic table to go from here to here. This tells me the tool to use. Now the next key factor is using your units appropriately. If you don't use units when you're setting up the calculation, it's super easy to make a mistake. So let's take a look at what those units are going to look like. I'm going to grab a different color writing utensil so it doesn't run into our problems here. Okay, so I'm going to start with what I'm given. 3.2 times 10 to the 24th atoms of sodium. Yeah, I know. I'm writing that whole thing out. And my students complain and gripe about that. But if you will do it, I'm going to tell you right now, when we get to stoichiometry, which is just 2 weeks away, it's the big deal. You got to write it all out. Otherwise, it's going to be a big mess. I know it takes some extra lead. It takes some extra paper. Trust me, it's worth it. I've been doing this for 25 years on the instructor side and way more than that on the student side. So just do it. Just suck it up and do it. It'll be okay. All right. Now, if I have atoms here, atoms of sodium, I want atoms of sodium here. Well, I'm trying to get to mole. Notice 1 goes with mole. So I'm trying to get to 1 mole of sodium. If you'll remember that 1 goes with mole, it'll help you put the 6.02 times 10 to the 23rd in the right place. The next trouble my students have is plugging this in their calculator correctly. Okay, I'm going to do this with 2 different calculators so you can see how this is done so that you don't make a mistake or hopefully make less mistakes. I want you to try this in your calculator too to see that you get the same answer I do. The first calculator I'm going to use is a TI. Let's see if I get trying to get that glare off. Sorry, my office lighting is far from perfect. Okay, so we're going to go 3.2 second E, or second comma, which is our E, 24 times 1, because we got to multiply across the top. Then I hit enter. Then I'm going to divide this, parenthesis, 6.02 second E, 23. And I get 5.3156, blah, blah, blah. SigFigs tell me I just need 2. So my answer here should be 5.3. You can't see that. There we go. Moles. Notice atoms of sodium cancel with atoms of sodium. My answer is in moles of sodium. Now, this same trick is going to work if we're starting with moles of a compound. Okay? Moles of a compound to molecules of a compound. If I look at my flow chart, I'm at moles. I want to go to molecules of a compound. I'm also going to use Avogadro's number to go here. Okay, so I'm going to start with what I'm given. And remember, 1 goes with mole. That helps me remember where to put Avogadro's number. And it says in 1 mole of any compound, 6.02 times 10 to the 23rd. And I'm going to write it out, molecules of water. Now, I will tell you, sometimes I cheat on the word molecules and write out molic, but you got to get all the way, otherwise people are going to think you mean moles. Okay. Now I'm going to do the math. I'm going to do it this time on this type of calculator. It's a little less fancy. Let me see if I can raise this up some so you can see what I'm pushing. All right, I'm going to have 0.67 times 6.02 second E23. And I end up with 4.034, and there's a space, you can almost see times 10 to the 23rd. Now, what I'm going to do there, I get 2 sig figs. Yeah, I know, that was the first month of class. We're still using it. 4.0 times 10 to the 23rd molecules of water. Again, you can abbreviate molecules with molic. I'll let you do that. It's okay. It's legal in most states. Okay. Now, those problems were dealing with molecules and moles, and moles and molecules. But what if we have a mass? Remember, our masses are going to be measured in grams. If I'm starting with a mass, notice to go from mass to moles, I don't use Avogadro's number at all. There's no 6.02 times 10 to the 23rd in that at all. I'm going to use the PT, or the periodic table. This is where my molar mass is going to come into play. So if I start this out, 33 grams of potassium. If I have grams of potassium here, I've got to have grams of potassium here. If I have grams, I go to the table. So if I look at potassium, I'm going to see that 1 mole of potassium is 39.1 grams. And remember, 1 goes with mole. So now I'm going to multiply across the top, 33 times 1. Well, that's pretty easy. That's going to be 33 divided by 39.1. I have 2 sig figs, so my answer should be 0.84 moles potassium. I can do the same thing for a compound. Remember, anytime I'm going from mass to moles, there is no Avogadro's number. We're just using the periodic table. So let's see if we can do that. We're starting with 2.7 moles of sodium chloride, or table salt. If I have moles on top, I've got to have moles on bottom. What always goes with mole? That's right, 1. Okay, now I have to get grams of sodium chloride. How do I do that? All right, let's think about this. We've got to do the molar mass. Well, I have 1 sodium and 1 chlorine. Sodium has a mass, if I look on the periodic table, 22.99. Chlorine has a mass, 35.45. So it has a molar mass of 58.44 grams. Now it's time to do the math. Moles of sodium chloride cancel. I'm left with grams. Fabulous. 2.7 times 58.44. I get 157.788. I get 2 sig figs. Ooh, scandalous. So 160 grams of NaCl. Okay, pause this. I want you to try the next one without me. No, I don't. The next one I need to show you. Just kidding. Okay, the next one is a big step. Check this out. I'm going from a mass to atoms. Now, if I look at my flow chart and I think about this like a airport map or a bus map, there's not a direct connection between mass and atoms. There's a layover. There's a stop you have to make in between. This also tells me how many steps are going to be in my problem, because I'm going to have to go from mass to moles, and then from moles to atoms. So this is a two-step problem. This helps kind of keep me straight on how to get there. So I'm going to start with 15 grams of Fe, and to go from mass to moles, my flow chart tells me that I'm going to have to use the periodic table. So for 1 mole of iron, if I look at my periodic table, that's 55.35 grams. Now, if I stopped here, my answer would be in moles, but I don't want that to be my answer. I want to go on to atoms. Well, to go from moles to atoms, this is where I'm going to have to use Avogadro's number. So 1 mole, because remember, I want these to cancel, is going to be 6.02 times 10 to the 23rd atoms. Now I'm going to multiply across the top and then divide by the bottom. Now I can do this a couple of ways. I can do it in 2 steps, or I can use the parentheses on my calculator, whichever I prefer. I always like to hit enter. Then I'm going to divide that by 55.35. And it tells me, I get 2 sig figs, 1.6 times 10 to the 23rd atoms of iron. Okay. Another term that I want to show you is formula units. I think this shows up in your homework. Molecules and formula units, for our purposes, are the same thing. Truthfully, a covalent compound makes a molecule, an ionic compound makes a formula unit. That's a more advanced topic that you don't really have to know anything about, but that terminology sometimes comes into play. So on your flow chart, if you wanted to write formula unit, that is totally acceptable behavior. We're going to find it the same way we did the other. But notice we're formula unit for a compound. We're trying to get to a compound. And I should have that in the problem too. That was scandalous on my part. If I have this many formula units of Al2S3, how many grams of Al2S3? I'm going to start with a formula unit. I've got to take it to moles. To do that, I'm going to use Avogadro's number. And then to go from moles to mass, I'm going to use a periodic table. So I've got 2 steps in this problem. So let's see if we can work this out. I'm going to actually do this on this paper underneath because I didn't give myself enough room. So I have 7.4 times 10 to the 21st formula units of aluminum sulfide. I'm going to use Avogadro's number. To go to 1 mole of aluminum sulfide. Now I've gone from formula units to mole. Now I have to go to mass using my periodic table. So I'm going to have the molar mass of aluminum sulfide. So I have aluminum, I have 2 of those, times, when I look on the periodic table, 26.98. Sulfur, I have 3 of those, which is 32.06. So I'm going to do some math. Then I got to add those together. So 1 mole of Al2S3 is 150.14 grams of Al2S3. Check to make sure everything cancels that I need canceled. Formula units cancel, moles cancel. I'm left with mass. That's what I want my answer to be in. So now I got to plug and chug in my calculator. 7.4, oops, E21 times 150.14 equal, divided by 6.02 E23, and I end up with 1.8 grams Al2S3. Okay, so what I highly recommend, practice, practice, practice. I've attached additional practice problems following this video, but it wouldn't be a bad idea to start on your homework early. Try those out, and then reach out to me if and when you have questions. I hope this helps. Have a great day.